Okay, let's keep going then. So here's another one we can do. So here, what we have is we're going to solve this system by elimination. So now, looking at this equation, right? It looks like, so here we have 4 times x, right? Plus 7y is -3. Well, we know -8 is negative 2 times 4. So -8 is, negative 2 times 4. So if we multiply the first equation by 2, we'll have 8x over here. And then we can add it to kill off x. So let me say again, here we have 4x, here we have -8x. So looking at this, we can say, oh, well, if we multiply the first equation by 2 and add, x goes away. So let's do that. So we multiply the first equation, both sides, by 2. We have 8x, 14y is -6. Right? That's our first equation has changed. So now our system becomes this. And I don't think I said this before. These two systems are actually the same. Oh, well, excuse me, they're equivalent. Remember how, like, when we were solving an equation, right? You know, we did certain steps, but there are only certain steps we can do because they did not change the solution set. With elimination, that's what we're doing as well. You know, I can't multiply both sides of this by 0, right? That's not going to help. Okay. All right. But you can add the equations together. You can multiply either equation by any number, any non-zero number, I should say. Okay. All right. And that will preserve the solutions to the solution set, that is. So here we have this system. Okay, now we can add the two equations together. So we add them. What happens? On the left side, we get 0. So the x is gone. We also killed off the y, didn't we? So x is gone, y is gone, and we have 0 on the right. So we have 0 equals 0, which is true no matter what. What does that tell us? That tells us we have infinitely many solutions. Infinitely many solutions. And so, in fact, these equations are, it's consistent, the system, but the equations are dependent, linearly dependent. Any questions on that? Okay. Here's actually one I was going to let everyone try. So I'm trying to get, again, trying to get the class to be, engaging, because I know this is virtual. So let me stop the recording. So for this one, we have another example, okay? So again, we want to solve it by elimination. So now looking at this, okay, we want to somehow eliminate a variable. Now, if you notice, we have -y in the first equation. Second equation, we have 2 times y. So if we took the first equation and multiplied it by 2, we would get -2y here, and then we could add and cancel y. Okay, so let's do that. So the first equation, we're going to multiply both sides by 2, as you can see. We have 2 times 5x minus y equals 2 times 5. Okay, right? We get 10x minus 2y equals 10. So the first equation becomes this. This is what we have. Now we can add, right? If we add the equations, you kill off the y, you get 13x on the left equals 52. And now we have one equation with only one unknown, x. Because of that, we can figure out what x is. How do we do that? We divide both sides by 13, right? Because we want to know what x is. So we have 13x equals 52. We divide by 13, and we get x equals 4. Since x is 4, we can figure out what y is. We want to go back to the original equation and plug in x to one of the original. So I went to the first one, mostly because the coefficient of y is 1. So we get 5x minus y equals 5. X is 4. We get 20 minus y equals 5. So of course you subtract 20 from both sides. Negative y becomes negative 15. And then of course you want y, not negative y. So we divide both sides by negative 1. We get y equals 15. So what we then have is 4, 15 as our only solution. Are there any questions on this? Okay, so this one we're not going to get to today. I figured we'll do the backup examples here next time. It's just more practice, basically. So let me stop this.